So now let's find the five-number summary and then find the range and the interquartile range once we have it for a couple of data sets. Our first data set represents the hold times and minutes for getting customer service help from phone company, let's call it A. And then the second data set is for the same type of data but for a different phone company B. All right, so let's start by looking at the data. First off, I've organized it ahead of time just to make it easier for us. That's the first thing you'd always want to do when finding a five-number summary, because the five-number summary includes values related to organizing that information into quarters. The first thing you want to know are the ends. So in finding a five-number summary, we're going to first find the minimum, which is the lowest value, 24, the maximum, which is the highest value, in this case 30. Then what we're going to do is look at the very middle of the data. Now this first data set for phone company A has 9 data points in it. So the median would be the single number, the single data point that is right in the middle. So 27 would be the median. Remember, how we're going to find the five-number summary and how we're going to split this data into quarters is to first half it, and then we are going to look at the separate halves and have those separate halves. So this is our first step of having it with the median. And so now we've got the min, the max, and the median. Now we're going to look at the lower half of the data and the upper half of the data. I do want to point out that because that median was an actual value, when we go to look at the lower half of the data, we do not include that median in the lower half. And then the upper half of the data will do the same thing. We do not include it. So we've got a lower half of the data and the upper half of the data. And we're going to find, once again, the middle of that. The middle of the lower half of the data will be the first quartile. Now the middle of these 4 data points that I have highlighted in yellow would be right in the middle between 25 and 25. Well, what's in between 25 and 25? It is 25. So Q1 is 25. The lower quartile is 25. The upper half of the data, again, has 4 values, and the Q3 would be halfway through. Now this time we don't have a duplicate of numbers. We have 28 and 29. Remember how we find the median for a situation like that is we look at what's halfway between it. 28 and 29, halfway between those would be 28.5. So Q3 is 28.5. So what I now have is the five-number summary. And you should always write a five-number summary in order. I kind of did it as I went, writing the min and the max, the median, and then the 2 quartiles in. So even though you list them, if I were writing this out, minimum, first quartile, median, third quartile, and maximum in that order, to find them, we actually do, we do them out of order. Now, looking at the range, which would include all of the data, the distance between the low and the high value, we would simply subtract the high or the maximum and the minimum, the low value. So the range in this for this data set is 6. And remember, these are all minute values, how many minutes you're on hold for. So one thing that is a good thing to do is to just always remind yourself that these numbers have meaning. So I'll just write minutes in for each of those. So the range is 6 minutes. That means the difference between the person who waited the longest and the person that waited the shortest amount of time was 6 minutes. The interquartile range, which we often abbreviate IQR, so interquartile range is IQR, would be the difference between Q3 and Q1. So 28.5 minutes minus 25 minutes, that would be 3.5 minutes. And what this is talking about, the IQR, is it's referring to the middle 50% of the data. So we're basically looking at the middle part of the data in essence. And what this is saying is that the middle part of the data is within 3.5 minutes. So when you look at the middle 50% of people in terms of how long they were on hold, the difference between their times was 3.5 minutes. So that's one data set. Go ahead and pause the video and see if you can replicate that process for the second data set with phone company B. Okay, hopefully you gave it a shot. Let's go ahead and look at it together. Once again, how we want to start this is we want to start with the minimum and the maximum. The minimum here is 10. Again, these are minutes. The maximum is 28 minutes. So we start with the min and the max because they're easy to find. Then what we're always going to do is look halfway through the data. Now this data set has 8 data points. So when we look halfway through, we're actually not in any of the data points. We are literally just in between the two ones in the middle. Now, coincidentally, these two in the middle are the same. So the median will be their same value, but neither one of them is technically the median. They have the same value as the median, but the median is actually between them. Then we're going to look at the lower half of the data, which would be 10, 26, and 27. And again, 27, that is then that lower half is not the median. It just has the same value as the median. Now we're going to look halfway between those data points. So we're halving this half. And if we half this half, we would be right here between 26 and 26. So Q1 would be 26 minutes. We do the same half with the upper half of the data. We have 4 values in the upper half of the data, 27, 27, 28, 28. So Q3 would be halfway between 27 and 28, so that would be 27.5. Okay. So there's our 5-number summary. Even though I found them out of order, if you write them down, you would always write them minimum, Q1, median, Q3, and the maximum. All of these are, again, have units of minutes. And when we think about the range would be the difference between the max and the min. The max here is 28 minutes. The minimum is 10. So it turns out there's 18 minutes difference between the person who was on hold the least and the person who was on hold for the most amount of time. 18 minutes between those two. The IQR represents where you're looking at 50% of the data, in particular how much spread is in the middle 50% of the data, and that would be 27.5 minus 26, and that would be 1.5 minutes. So let's compare these two data sets in terms of these calculations. Starting with the range, when we look at the entire data set, looking from the high to the low values, what we see is that phone company B had a more varied range, a higher range between the max and the min. So the hold times were more varied than for company A when we include all of the data values, which is what the range does. However, when we look at the IQR, we see something else. In the IQR, we see for phone company A that we have a wider width of times or wider range of times in the middle 50% of the data values, 3.5 minutes, compared to in the for phone company B, there's relatively little difference within the middle 50% of the data. The middle 50% of the data is all within 1.5 minutes of each other in terms of hold times. So the IQR for the phone company B is tighter, and that means that the data is less spread out, at least in the middle 50% of the data. Now, why do we have this difference? Well, if you think about this range for phone company B, part of why it was so large is because we had an unusual value. Again, we had that minimum, which was unusual compared to the rest of the data values. If we were to exclude this minimum of 10, the rest of the data values would be very tightly packed together for phone company B. But because that 10 is in there, it does extend the range and make it initially seem like the data is much more spread out. So this is an effect that outliers can have. Again, outliers can really affect means and they can affect the range. They're less likely, in fact, they rarely affect the IQR. In fact, they don't affect the IQR unless you have a very tiny data set, because the IQR is only looking at the middle 50% of the data, which is not where you would have outliers.